These are some prismatic type LiFePO4 batteries, 3.2 volts, 100 ampere hour. Now, if you have a closer look, you will see one terminal is aluminum while the other one is copper. Now, this is the most dangerous part because of which these batteries lose their life or get damaged. But you don't have to worry because I will be sharing with you a solution for that later in this video. So this is my new BMS. These are the wires. This is the main BMS. It is of the DALY company. Link will be provided in the description. You can see that it is 250 amperes. Here you can see 4S to 8S. That's the cooling fan. Really thick and powerful bus bars. Nice, really nice look and quite compact. So this is the one that I will be using. Next, these are super thick wire that we get for connecting the BMS and the battery and for load driving. So these are the dimensions for a single cell. Recently, I got my kitchen built and these action Tessa wooden pieces and boards got left behind. So I thought about reusing them in my future projects. This is going to work out best for my LiFePO4 battery pack. Otherwise, I would have to buy separators and the casing, but this way I can build my own and it is going to be fire resistant and water resistant, unlike the normal wood which can burn easily in case of overload, short circuit or explosion. These are all the wooden pieces and parts that I have cut with the laser. Now let's do the voltage check of each battery. 3.314, 3.31415. So the batteries are perfectly balanced, and I expected no less as I have been using this BMS. It is 200 amperes and it has been balancing these cells for around a year. So here, as you can see, that the final board is placed very precisely. There is no gap and the foam is completely compressed. Here you see the thickness of the initial foam, and here as you can see that the foam is barely visible. It is compressing the batteries perfectly. Here you can see that I've placed the batteries in such a way that aluminum terminal faces the next with copper one, then aluminum, then copper. This is necessary to easily connect the batteries in series. Now comes a very important part that people usually don't tell or miss out. A battery has two terminals, one aluminum, other one copper. The copper one is already coated with the nickel through electroplating. Now that layer is very thin, so don't ever use sandpaper on the copper one. Only use sandpaper on the aluminum one to remove the oxide layer. For the copper one, simply clean it with a cloth. That is fine, because if you use sandpaper on the copper one and it removes the nickel electroplating, it is going to expose copper, which is thus going to cause corrosion to the terminal. So here I'm going to use these copper bus bars to connect the batteries in series. They are really thick, as you can see, so can easily handle 100 amperes. Here I've made this mark on all the bus bars for drilling the hole. Here are the three copper bus bars with perfect holes for fitting the batteries. Now, copper and aluminum are not friends at all. They are going to cause corrosion to each other and then finally disconnection. So I'm going to tell you the trick for this also. So watch it till the end. After cleaning up the bus bars, they should look somewhat like this. You can see that I've cleaned up only the connection area. This one is like this only. So now it is time to connect this BMS to the batteries. Here you see it is showing P negative, and you will get a black wire like this labeled P negative. So connect this wire to any of these 2 points. Both are the same. So I'm going to connect it here. Next, this is B negative, B negative. Okay, so you will get another blue colored wire that is B negative. This will be connected to either of these 2 points. So this time I will choose the lower slot for connection. And the reason is that the wire is longer and I don't need that much length. Now, this copper terminal of the battery is the negative terminal and aluminum one is positive. So proceed with the connection of this B negative terminal to the negative terminal of the battery, the first battery. But make sure that you also use these extra wires that you get with the BMS. I have connected these connectors. So the black wire, it is quite separate. That will be connected to this battery terminal along with this B negative. So simply use one of the bolts that come with the BMS and connect it to the battery terminal. Yeah. After that, use your electric screwdriver. Make sure that you don't do it too tight to protect the threads. That is good. And while connecting these wires, make sure that you have not connected these pins to the BMS. I will do the wiring and then check everything is fine, and then only am I going to connect these pins to the BMS. Next comes the most important part that I'm going to tell you in this video. These bus bars are not coated with anything, like not nickel or neither tin. So we cannot connect these bus bars directly to the terminals because one of it is aluminum. And as I said, copper and aluminum don't go well together. There is corrosion. So what I'm going to do here is I am going to use these zinc coated washers in between the bus bar and the aluminum terminal. Now this is not the perfect method, but right now I'm going to do it, and I am planning on ordering the bimetallic washers. A bimetallic washer is something like this, and the upper side is copper while the lower side is aluminum. So that is going to work out best. Or if you can find a bus bar that is nickel plated and it should be copper inside, then that is even better. But in my area and even online, I cannot get those kind of bus bars that are nickel coated. What I am getting are the steel bus bars that are worst because of high resistance that will cause heating and ultimately damage the batteries because of excessive heating. So let's start with this. And one more thing, coming to the pin outs, the first wire is the black one and the one next to it is the blue one. So take the one that is right next to the black one, that will also be connected to the positive terminal of the first battery. So let's do the connections for all. So I've taken one washer, one this type of washer that is cut, and the other is the bolt. Let's install these. So the process is that here is the aluminum, placing it like this, and I've already sanded the terminals, which is must. After that comes the bus bar, placing it like this, and yeah, I've placed this wire, the one I told you, then the cut type of washer, and here it goes. It is loosely connected right now. After that, I will do with the electric screwdriver process. So the sense wire is connected. Now comes another washer. This one is already copper and we don't need a washer for this, but we still have to place the washer because the heights are going to be uneven. So the first bus bar is successfully connected. Going on to the next one, same process for the other bus bar. These two terminals will be connected in series. So let's take two washers. Finally, we need a bolt and this type of washer. Okay, here we used the first blue one. Moving on to the next one, will be connected here. So here we go. Finally, the next bolt and the washer. Then moving on to the final bus bar, and now we're going to need the third blue wire here. Now, important part is that you get this manual with the BMS, cross-check everything, and then connect these pins to the BMS. Also, I have placed this heat shrink tube to cover up the cable. I still have to shrink them, and I have tightened up the bolts after rechecking, and everything is fine. Next, there is another pin out. I'm not sure what it is going to be used for, so I am going to leave it disconnected. Next, I have coupled all the wires with this heat shrink tube, although I have to shrink them, that I will do later. And I've also placed this Wi-Fi that you get with the BMS. Its cable is also coming through the heat shrink tube. Finally, this is the red wire that says B plus that will be connected over here, but first I will have to shrink them, and I also have to connect this temperature cable. Now this temperature cable will be connected to NTCA. Now let's shrink the tube, that let's cover the rest of it as well the same way. Nice and strong. Finally, this cable is for the Wi-Fi, so let's connect it to UART. Then temperature 1 done, UART done. Finally, I'm left with the B plus and these cables. Next, here I'm using this double-sided tape to stick the Wi-Fi sensor. Moving on to the final connections. First, let's connect this cable. There should be a clicking sound. Finally comes this B positive. So I'm going to connect it over here. Done. So here you can see the lights. It is green, which means everything is fine. And this will glow red in case if you didn't connect the temperature cable, this black one. So once you connect it, it is going to glow green, and it might also glow red if it is like balancing the batteries. Next comes another very important part, which is connecting the final temperature sensors to the battery. These are going to sense the temperature and tell the BMS if everything is fine or not. Alright, so you have to take these sensor wires out, and from below the cable wires you have to take these sensor pointers to the second battery, and after that I'm going to use this black tape. Okay, and these sensor wires will be placed on this battery surface in the middle of the two terminals of the battery. Finally guys, the connection parts are fully complete. You get this wire with the BMS, although you will have to buy the positive cable. This is from an inverter, and it will be connected to the last terminal, which is the final positive, and this black one is the final negative. These two will be connected to the charger or to the load. Now finally it is time to apply this battery terminal protection gel. Link for these and recommended products will be provided in the description or the pinned comment. You can check them from there. Make sure that you have cleaned the terminals with a little alcohol and some cloth that has already been performed. Now it is time to place this. Now the most important ones are the aluminum ones. I'm using this metal piece, so I have to be careful, otherwise I can short the battery terminals. Take your time and be very thorough. You don't necessarily have to apply a very thick layer. A thin layer will do the job well enough. All it has to do is to prevent the oxygen from getting in contact with the surface. As I said, I'm majorly worried about the aluminum terminals because they are connected directly to the copper bus bars, like not directly but with this zinc washer in between, but still this is a nasty combination. I will replace these zinc washers as soon as I get my bimetallic washers. Now that the main job is complete, you can put the leftover on the remaining terminals, and there are also terminal protection sprays that are available in the market for you to buy. You can also buy those. The truth is, I too have ordered one of those. Those are really helpful in battery protection, any type of batteries. I will place the link for those also in the description. So now the battery pack is fully complete, and all I have to do is show you the charging and discharging process, connecting the loads, and show you its remote monitoring. Time to test the overall battery pack voltage. It is set at voltage measurement mode, red wire positive and black negative. And here as you can see that it is showing 13.29 volts. So it needs charging. It is like somewhere in the middle. Moving on to the remote monitoring. So here is the DALY app. Here you go to BMS device. The name of the devices will be listed here. This is my 100Ah new. Yeah, let's click on it. Connection is successful. SOC is 53.4%, and I've said everything. Here you see the battery voltage. It is showing 13.3 volts, current being 0 amperes since it is not loaded at all, and capacity is 53 ampere hour. I think I will have to update it. It is not 53 ampere hour, it is 100 ampere hour. Anyways, and the temperature sensors, they are measuring 22 degrees. Here are the settings. See, single over voltage protection is 3.6 volts. Single under voltage protection is 2.95 volts. Total voltage over voltage protection is 14.4 volts. That is maximum. Total voltage under voltage protection is 11.8, and so on. The charging over current protection 60 amps. So discharge over protection is 250 amps. That is because my BMS is 250 amps. Next, I'm going to show you the charging process with this SMPS power supply. Okay, it's connected to my home socket. Connected. You can see the lights here. Here you can see it is showing 14.4 volts that I've already set. Finally connecting the wires. Now here the white one is negative. So for that I'm going to use this black clip. And this is the main battery negative wire. Let's connect them together. Done. Finally the blue and the red wires, they need to connect together again. And should passing. Yeah. Once the charging starts, the SMPS voltage will drop. You see here right now it is 13.9 only, which initially was around 14.4 volts. It is now only 14 volts because of the voltage drop. And let's do the current test. Yeah, it is already set at DC ampere measurement. Let's do the check. 20 amperes is what is being drawn from the SMPS by my battery pack. So the safest and long life charging current for 100 ampere rated battery pack is 20 amps, and 30 amps is also fine. But as you go higher and higher, it is going to be like not very good for the battery pack. It is going to reduce the number of cycles that you get. So better to stick around 30 or 35 amps. That is a sweet spot where you get fast charging as well as long life, higher number of cycles. Now let's proceed with some load testing. I have some bulbs here. So the 12 volts LED panel, these are like very low load, so I'm not going to try it. This is the car headlamp, 80 watts night eye. Let's connect it, and so prime. Obviously it can easily power it up. And next can be our car headlamp. This is a 55 watts incandescent bulb. See, I have this one also. Let's try this. This is a 90 watts car headlamp, old model. This is a big 12 volts 22 amperes permanent magnet DC motor. Let's test it. So these were all DC loads running at 12 volts. Let's move on to 220 volts AC loads. So I have this inverter, and it is really good. I have not been using it for many months. It is around 3 or 4 years old and still works perfectly fine. It is pure sine wave and 1500 watts with a peak output of around 3000 watts. So let's connect it. So black one is the negative terminal. Make sure that you connect it really tight because large amperes are going to flow through it. So here I've connected the inverter finally. So this way you will be able to see the display of the inverter, turning it on. Here you can see 13.3 volts and the output finally 225 volts. So link for this product will be provided in the description as well. So this is my 350 watts drill that I have not been using for many years, lying around discarded. It is working, but I'm still not using it because I have a better one. See? Yeah, I understand that it is no load and it is not drilling anything, so it is not much loaded, but still it is just a demonstration. It will definitely handle that kind of load. This is my another drill machine. I like using this one. Now we can safely use a higher current rated BMS, but not vice versa. We cannot use a low amp BMS for 100 ampere hour battery pack. And I'm using this one because I want to extend my battery pack in the coming days. So I bought this one first. So that's it guys. Thank you so much for watching this video. See you in the next one. Bye bye.